Guys, today we're going to be doing a WebEx video that hopefully is going to explain the last of the three simulations. This one involving linear regression from chapter 8, I believe. So let's start by sharing my screen before I forget. Let's move into Excel. Oops, let's start a new one. File, new. And let me look at the list of items. Okay, so the first thing is we're going to generate 15 pairs of random integers between 0 and 9. That's the population that we're using. We want to pick random numbers because we know the answer before we start. Also, it's much easier than doing a survey. So let's do that. We'll call this Y1. And equals rand between click 0, comma 9, enter. And the computer picked for us the number 1. Let's pick a corresponding Y value. Now again, it changes, of course. A little disconcerting, but it does. And even though in the original version of this for those of you who might have done it yet, and you don't have to repeat it if you did this, I asked you to pick 5 pairs of random numbers. Now I'm going to be asking you to pick a slightly more realistic sample of 15 pairs of random numbers for those of you who are doing this for the first time. Now, from these pairs of random numbers, I want you to calculate the regression statistics between them, including the correlation. Again, this only makes sense if you've done chapter 8. And like always, I point out that in the videos that I've made, the YouTube videos, I explain a lot of these concepts in much more down to earth and in more detail, if you want to understand the theory a little bit better. But we need the correlation, the slope, and the intercept, and the p-value between them. In other words, is a significant relationship. Now, we don't expect a significant relationship because they're random numbers. These pairs of numbers have nothing to do with each other. They're picked out of the air, literally. Well, it's interesting how the computer picks random numbers, but that's another story. So we can go to data analysis, regression, which is here. Okay. Tell the computer that we do have labels. Tell the computer that the Y range, which is the second one, because X impacts on the Y. The X range is the first one, usually the order that it's done in. What else do we want? Let's put the output right here. And as opposed to a new workbook, I think that's all we need. We don't need this. We don't need that. Line fit plots. Maybe let's ask what happens there. And let's see what we get. Okay, so, So we know that the correlation happens to be the multiple arc, and this same printout works for multiple correlation and also single linear correlation, just simple, only two variables, one X and one Y. So correlation is 21. If you square 21 point, you're going to get this, which is the R squared. The p-value can either be found here. It's 4779, which is bigger than the alpha cutoff point that for this assignment is 10%. Usually it's 5%, but in this assignment, for purposes make clear later, I made it 10%. The same number here, significance should be right here, 4779. The significance of the X variable as a predictor. So basically, there's no significant relationship between them, and you can see that the plot. I don't know why it's not a straight line. The predicted should be a straight line. Meaning that as the X gets, well, let's see the slope. The slope is 0.19. Well, positive 19. Well, anyway, it should be roughly a straight line because there really is no prediction between the x and the y. Anyway, they want you to repeat this 20 times. Now, it turns out, I'm going to get rid of all this. Turns out that you can repeat this. You can calculate the slope, the intercept, and the correlation by using Excel functions. So for example, we can do the correlation, CORR equals, and then pick a function equals car and CARL. You type in the array one, it doesn't make a difference if it's X and Y for correlation. Then we'll do A2 A15, comma. The Y variable is now Y2 to Y15. Hit enter. And the correlation is in fact a minus 0.25, meaning as one gets bigger, the other gets smaller, but that's just an artifact of the fact that they're random numbers. There's no real relationship between them. The intercept also has a function in Excel, as I discovered. These are the Y's, comma. These are the X's. Enter. And now we have an intercept. Now you'd expect the intercept theoretically, and I'm giving you a hint at some of the answers to the verbal questions. You'd expect it to be around 4.5, which is the average. Again, since X can't really predict the Y, the best prediction you can make is what you expect the average to be. Anyway, that's a hint for some of the other. And finally, the slope equals slope, parenthesis. Again, we put the Y's in, comma, put the X in, enter, and the slope is minus 29. Usually if the correlation is negative, the slope will be negative and vice versa. Okay, now, because we have it down as a formula, we can drag this over 20 times to produce all the relevant numbers except for, we have to do one more time. I think we have to do one more. Let's get rid of this one. The elite has to be an even number. Let's pull over one more. 19, oh, 18, 19, no, my mistake, sorry, 20 times. Okay, so now we have the raw material for setting up the table that I asked you to do. I asked you to summarize for the 20 rows, 20 to create a table, a table with 20 rows. Each row, one column would be the trial number, 1 through 20. The second column, this is on the sheet with the instructions. The second will be the slopes, then the next column will be the intercept, the third column will be the correlation, but the fourth column and the fifth column, which is the p-value, I couldn't figure out how to do using a simple Excel function. There are ways of doing it by defining your own function, but it would be more complicated. So the easiest way to do it is to pick these numbers, go to data, go to data analysis, go to regression, hit OK. Everything here should be the same, pretty much. Hit OK. All right. Okay, so again, so we have the significance. What you're looking for is the significance of f, and again, that number will reappear over here. The p-value. Looking for the p-value of this whole thing, of the whatchamacallit, of the x predicting the y, which is 0.61. So and then you would repeat this again for the second pair of numbers. You would go to data analysis. Okay. This time it's oh, they're using the same A and B again. Let's just see. Last time it was point. It was point 61. Let's see what happens if we do it again. Okay. 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 Yes, it changes because every time you just can keep focusing on the first two because every time you use it, it's going to change. It's going to change the numbers. Let's try it again. 4, 6. I want to see if this works. 4, 4, 6. It's 4, 6. Let's see if those numbers change. My own curiosity. Data, data analysis, regression. K, K, okay. And yes, it did change in the middle. So you could do this either way. I just want you to produce 20 of these p-values. Now it's 0.80 and create that table. Okay, so we have that. That's how you would produce a table using Excel. Okay, next. That's part one. Part two says, let's go back to my new revised version. Okay. Part one, part two, part three, and part four. I'm not going to give you the answer, so I want you to think about it. What is the average slope? By taking an average of all those 20 slopes that you have, get the average intercept by taking an average of the column of all the intercepts that you have. And I say someplace that I don't want you to do this in Excel to hand it to me, but you can hand it to me as part of an Excel file, as long as it's marked part A, part B, part C, 1, 2, 3, etc. And I want you finally to explain why the answers make common sense, why you would expect those numbers. Okay. And again, the hint is found in the YouTube videos that I gave. But again, also, if you get it wrong, you have the opportunity to send it in if there's enough time before the end of the term, and you'll get back some critique, and you can always fix it. Now I want you to do this one last time. Instead of using 15 pairs of numbers, to take 1,000 pairs of numbers, which obviously is much more exact as representing the whole population of random numbers. And I did that somewhere. Here it is. Nope, not here. I have it somewhere. Open file. Think. Oh, here we are. I already prepared the 1,000 pairs of numbers. Easy enough to just drag it down on Excel. But because I want you to use StatCrunch for the next part, and it's easier to generate the random numbers in Excel and bring them into StatCrunch, I did that. So we have okay, so I'm going to get rid of this temporarily. I'm going to get rid of this temporarily. And, oh, I did want to save that, by the way. And now we're going to go into StatCrunch. So StatCrunch. You pull them in. The way you pull them in is you go into Data, Load, From File on my computer, and then you browse to the file where you saved the 1,000 pairs of random numbers. You could generate random numbers in StatCrunch as well, but I don't see why you'd have to learn that. Now, so we have the 1,000 pairs of numbers. And what I want you to do with those 1,000 pair of numbers are more or less the same things I asked for with each of the individual 15 pairs of numbers, but you can do it very easily in StatCrunch. Stat, regression, simple linear. Now, it's not simple, but simple means there's only one X and one Y as opposed to multiple linear, which you learned about also in Chapter 8. So simple linear. And you tell the computer which is the X column. You tell the computer which is the Y column. There's no where, there's no grouping. You want hypothesis testing. You want a prediction. Later on, we're going to ask for a prediction interval when X equals 5. Assuming they're related, what would you predict the Y to be if X is equal to 5? And to create a 95% prediction interval, I want you to create a plot with the prediction interval. That will help you get the plot that you're supposed to do. And you hit compute. I believe that's it. Yep. Let's see what we did wrong. X1. Let's try it again. Stat, regression, simple linear, pick the X variable, pick the Y variable. The question is make a prediction when X equals 5, which of course you can't do because they're not really related, but we can go through it and think about it. 95% prediction interval. Transformation, no graph. I want a prediction interval. Here it is. Okay, so this time it worked. What didn't work last time? And if you go to the next picture, you get, this is the scattergram. Now again, we have 1,000 pairs, and each one goes from 0 to 9, and the Y goes from 0 to 9. So it looks like almost like truly random. And the line on top is called the prediction interval. The line at the bottom is the prediction interval because it's, we're predicting a higher and a lower value, like a confidence interval, except we're making a specific prediction. This is the regression line that goes down the middle. So here you have all your output. You have the estimated slope, estimated intercept. And you think about why that number is as it is. The estimated slope, the p-value, which is 0.7603, and the 95% prediction interval, which is minus 1.2 to positive 10. Now, again, the numbers can only run between 0 and 9. So I want you to think about what that strange interval is telling us. Okay, I believe that's all I wanted to say about this. Let me check one more time. One more time, I'm going to check the assignment itself. Explain. So a lot of explaining, but boils down to common sense. I want you to think about this to help you with A, your statistical skills, B, your Excel skills, C, your simulation skills, and most importantly, your critical thinking skills, which we'll be discussing after you send it in and it's graded. All right, good luck, and that's the end of the 3 simulations for now.